All right, recording is rolling. It is Friday, January 27th. So we're going to look at some color theory, additive and subtractive color mixing. We'll do this retinal fatigue activity, and I have a kind of activity for you guys. About to give you guys this template while I'm rolling some videos, and we're going to do a construction project that involves some glue and some string. And okay, so a lot of you guys saw this already. By this point, everybody's taken the simple harmonic motion quiz. So those are back in your folders. I have posted the solutions to Google Classroom. So if you wanted to do corrections, then you could do that and get them in. All right, so let me switch my screen over here. All right, let's kick off with rainbows. How about that?
You know, if you have a glass prism, white light hitting it, different colors will travel at different speeds and fan out as a spectrum. And if you had a mirror here, that spectrum could be viewed back here, huh? Well, that's what happens with raindrops in the sky. They act as little prisms. White light coming in fans into a whole lot of colors, huh? If you have your eye down here, you can see the colors. But why the bow shape? Major, I think I can show you how with the help of my model and this model as well. This is Major. What happened? White light happened? Let's try over here again. A raindrop up in the sky. White light coming from the sun comes down. And right now, Major's head is in such a place she can see blue. But where else can she see blue? Turns out she can see blue from a drop here, here. See? And we get a bow shape. And you know what? Seen from a high-flying helicopter, we get a complete circle. So all rainbows are completely round. It's just down at a ground level, the ground gets in the way, cuts them off. Hey, physics, yum.
All right. All right. Oh, question for you guys. If you zoom in on your cell phone screens, there's really only 3 color lights that are on your cell phone screen.
Red, green, blue?
Red, green, blue. Yeah, it's called RGB standard. Let me Google this for you guys. All right, so skips over here. All right, there you go. Yeah, so if you zoom in on a screen, yeah, that's really what it looks like. So if you have like white light, like a white screen, then they're all lit up. Okay. Wait, how do you get a black screen? Yeah, they're all off. Yeah. All right. So if your phone screen's off, it's black. All right. If they're all lit, it's white. Here's if you put all the colors together, you get white light. Humans have like 3 color cone detectors. We have 3 different types of cones, right? One that detects red, one that detects green, one that detects blue. So if you have those, then you can put together any of the colors you can see. Unless you're colorblind, you might be missing like 1 or more of those. Oh, yeah.
So then, looking at the screen and you only have like some black on it, does that mean that only the pictures in that blue turn on? Or do they not turn on?
Yeah. Like if you're reading text and the text is in black font, yeah, then those pixels are off. Yeah, and then the white background, those pixels are on. Yeah, and then all of them will be on for white light. Okay. I've got for you guys. How do you get wait, if the 3 colors are RGB, how do you get like yellow?
Blue and green.
Ooh, yeah, 2 of these here. Right. So here you go. Here's yeah, there you go. Yeah. Here's 3 colored lamps. You guys see there's a green lamp, a red lamp, and a blue lamp. Oh, look, red, green, blue. That's RGB, right? And then, hey, if you put all the colors together, or in this case, these 3 lamps, you get white light in the middle. Here's yellow. It's like the average of red and green, right? Here's like a cyan type color, right? Which is between the blue and the green, and like a magenta color between the red and the blue, right? So, like mix those, right? But now that's called additive color mixing. So that's like if you like start from nothing and then you start turning on those colored lamps one at a time, you can eventually like get to white light, right? But you probably notice like the opposite effect if you are like mixing paints, right? So Chris, what happens if you have like a whole set of paints and you mix all the paints? What color do you get? Yeah, like really dark muddy brown, kind of get tend towards black, right? Okay. Because mixing paints is actually the opposite of this. It's like subtractive color mixing. Now, don't write this line here. Maybe I'll Google this one too. Let's see if we do this. Because I didn't print out this poster, but you guys see like a poster up here that shows additive versus subtractive color mixing. Here, let me do this. Let's go. Additive and subtractive color mixing. All right, let's check this out. All right. Hey, what are the 3 colors in your ink printer? Right, you go home. Well, you probably have a black cartridge, but besides that, for your color printer, you have 3 color cartridges. Yeah, here they are right here. Yeah, so yellow is, yellow is one of your colors, then magenta and cyan. And what happens if you mix specifically those three colors? What if you do yellow plus magenta plus cyan? What do you get? Yeah, you actually do get this middle one right here, black. Yeah, right. And how do you get into these other colors? Like, how do you get green? Oh, well, that's yellow plus cyan is going to make green. Now that's subtractive color mixing. Subtractive color mixing is like whatever color you see is it's like it's absorbing all the colors except for that. And it's reflecting that into the world. So like yellow ink is absorbing everything except for the yellow, and it reflects like the yellow back into the world, right? But then okay, so yellow is really like green and red, so it's really reflecting the greens and the reds. That's why you can get the green and the red from that. Like I said, right, so this is maybe a hint that color is not like an intrinsic property like atoms. Like what color is a carbon atom? Well, no such thing, right? It's really like what wavelengths of light are reflected from that material surface into your eyes, and your eyes are picking up those wavelengths and interpreting them as different colors. Let's do this retinal fatigue activity here. Right. So, okay, you guys see that dot right in the middle of the flag? Stare at that dot for about 30 seconds, and I'll tell you guys what the purpose is, what's going on. Okay. You guys know, like if you walk into a bakery and it smells like bread and it smells delicious, and then if you're hanging out there for like an hour, you don't really notice it anymore, right? Because your senses get used to your environment, and then your brain starts looking for changes in your environment. So it kind of normalizes whatever's already there. And here's the visual version of this, and it's called retinal fatigue. So those colors are being stamped on the back of your retinas, just temporarily. It's not, right? So hey guys, what's like the opposite of black? That'd be white. So everything is black should turn to white. When I'm going to flip the screen and show you guys a blank white page, right? Your brain's going to show you guys the opposite of what's there because your brain's getting used to the colors that's there. Huh? What do you guys think the opposite of that cyan is? Probably going to be red. You think, right? And what do you guys think the opposite of that yellow is going to be? Maybe like a nice deep blue. Right? All right, you guys ready? You guys still staring at that dot in the middle? Boom. It's like an American flag floating there, right? Red, white, and blue. Okay, yeah, it's off for like a second. Yeah, so some people works better than others. Yeah, see it floating around there. All right, very good. All right, let's do Benham's wheel. Oh, hold on. Hey, yeah, let's do Benham's wheel here. Benham's wheel. Okay, actually, I'm gonna mute this guy and then zoom through this a little bit here. So, all right, you guys see clearly this wheel is just black and white, right? It's got this black like stripes that fit some kind of raised curvature. It's going to get this thing in motion. So here's more evidence that color doesn't really exist so much as it exists in your mind, but that's really what color exists. Right? Now this works for some people, but not everybody. Now I can see some colors. They're not super vivid. They're kind of dark grayed out. But I'll tell you guys what I see, and you may or may not see this. To me, the inside ones look kind of like a deep purple. This stripe looks kind of red. This one looks kind of gold, and this one looks kind of green. Or maybe you see slightly different colors than I do. All right, so here, show of hands. How many guys kind of see some colors in those bands? How many guys see some colors? Is that about half the class, I think? About half the class worth, right? Yeah, they're not like super vivid, but they're kind of there. So that's called a Benham's wheel. Right? So again, the colors are really just created in your mind. Right? It has to do with like what wavelengths of light are. There we go. Oh yeah, when we spin it faster, maybe it's a little bit better. Right. All right. Now, another thing to keep in mind is that, well, okay, this is a video and might be like something like 30 frames per second or something like that. And sometimes there's like a camera effect too. So maybe this will work better in real life. And that is one of the things we're going to do today. So let me switch my screen back over here. Okay. I've got some examples for you guys. Let's look at Newton's wheel. You guys have probably seen this in my classroom, right? So you can see a bunch of different colors, and I'm gonna give this thing a spin on the back, right? And what happens when you put all the colors together again? Yeah, like like a white light. Oh man, I'm looking at this on the camera, it's not working. Okay, so if you're watching this video at home, I'm seeing two different things, right? So in real life, it's like a beige, like almost white, like it's almost like whited out. Okay, on the video. Yeah, it didn't work so well because again, it has to like a framework rate and stuff. So okay, so if you're watching this video at home, it didn't work super well, but in life, actually in class, it did. Right, so this thing like pretty well turned white. Okay, now it had to spin really fast though, right? So you guys remember back a few months ago doing like mechanical advantage with the pulleys? Right? There's a similar thing going on here. You guys see how I'm turning it versus there's this belt that turns like this little, okay. You guys see this radius compared to this radius? That's a large radius compared to a small radius. Okay. You guys think if you do that divided by that, right, you get like a mechanical advantage going on? So if I give this thing like one rotation, there's one revolution that I turned it. Think this thing turns many times? So let me show you guys. So if I do exactly one rotation, I'm now behind one rotation. See how it turned like many times? Right? It's the same thing as the ratio of this radius compared to this radius, like how many times. All right. So you need this thing to spin really fast to make it work. Okay. Yeah. Sorry, that's not working on video, but oops. Okay. All right. But that's what we're gonna do because I just gave everybody this template right here. And so you guys got that template. You guys got some scissors, some glue, and some string. You guys got all these things. Okay. We're gonna do two. We're gonna make a Newton's wheel and a Benham's wheel. We're gonna get a 2-for-1. They've got some models ready to go. So here's one I made last class. This is pretty much exactly what we're gonna do. Right. Now where we're gonna get the spinning really fast is we're gonna make use of some string. Okay. So yeah, take a look at the final product. You guys get an idea how this is gonna go together. All right. So you guys see a couple of strings here. Right. Now, see there's like some depth between these two. Right. I did like an accordion version last class. Actually, I'm gonna repeat that because that worked really well. Right, like the square shape. But I need some space because like if I just glue the two discs together like back to back, the problem with that is that if this distance is bigger than this distance, it actually wants to rotate around this axis like this, which is no good. That's not what we want. Do we want it to, oh yeah. You don't have to turn it in, you can keep it, but as long as I see you working on it, I'll give you points. Right. So yeah, so you're gonna get points in the grade book for doing this. But you can keep it. So you're gonna walk home with a Benham's wheel on one side and a Newton's wheel on the other side. Right. Anyway, we want this thing to rotate this way. Right. It has something to do with like moment of inertia, like the correct moment of inertia, like axis rotation. Right. So we're gonna get this thing wound up. Sometimes you can like take the string, just like go like this, and it'll wind up. But you gotta find space right here. So sort of do it this way, guys. Yeah.
I don't think I have.
Oh, okay, yeah. Here's a template right here. Okay. Okay. And then so for demos for you guys. Okay. So because you I don't think I was quite wound up enough, but you guys get the idea. Okay. If you have this thing wound up and I've got a loop of string going through, so I'm gonna pull both ends taut. Okay, then this thing will see how like get spinning like that. Okay. And then from the side you'll see a Benham's wheel, and then from the other side you'll see a Newton's wheel. It should like turn white. Okay. So you can take this home, show your siblings and parents, show your friends in your other classes. Like, wow, that's so cool. All right, so that is what we're gonna do. That's the class here. So go ahead and cut out each of these wheels. I didn't miss anything, right? Everybody's got a template. Everybody's got a template. Okay, cut out these wheels.
Yeah, go ahead. So once you cut that out, what do we do?
Yeah, so I'm taking you guys through step by step. While you guys are finishing cutting this out, here's one I made last night. I did a little bit different method. You could do a version of this if you wanted to. I'm going to do the accordion method, right? But you guys remember past projects have you guys like make cylinders and cut each of the cylinders and go that way, right? So you could do this. I mean, this one feels a little over actually quite a bit sturdier, or so I don't know. This might have advantages or disadvantages. If you want to do a model like this, you can. But really, what you're looking for is like this gap. You want to be a little bit bigger than the distance between the two holes that you're going to punch in the middle of the or near the middle of each wheel. And so you want this gap to be larger than the distance between the two holes. So like 2 holes there. Okay. Oh, also I gave you guys a pastel version of Newton's wheel. the bright color version of Newt's wheel. It works, but like not as well. It's more like a big pink color. But the pastel one pretty well goes to like white. Okay. So okay. So most of you guys got both of these. Some of you guys are getting pretty close. All right, I think you guys are ready to punch some holes on these. Now, where did? Okay, so remember, you want the gap between the wheels to be larger than the distance between the holes. So I'm about to punch the holes, but keep that in mind that you want the holes to be kind of close together so that it gets the correct moment of inertia, so they'll spin along the correct axis. Okay? But not so close that when you pull the strings taut that it like tears through, right? So I think a good compromise distance is like about 1.5 centimeters. So what I'll do is I'm going to line up the ruler right on the center dot. So start with the Newton's wheel. I'm going to go like 3/4 centimeter one way, which is like 7.5 millimeters, and punch a hole right there. And be really careful with how you punch a hole. Bam! Make a nice clean hole right there. Okay. And then go from the center of the wheel straight across from it, because remember you want this thing to rotate right about the center of your wheels. The 2 holes right across from the center. Go 3/4 centimeter the other way, about 7.5 centimeters. 7.5 millimeters, and bam, right there. All right, got a couple of holes. Just like that. Okay. You do the same thing to the Benham's wheel. Remember, you want the same spacing holes so that when the string feeds through, it'll you can align these holes like right on top of each other. In fact, that might be a good thing to do. Actually, I didn't think about that. It's actually put one wheel right on top of the other wheel, right? So for sure the holes are going to align, right? Okay, and so I can kind of get that line matched up. Pretty close. Right? Okay, so I mean they're the same size wheel, right? So they should align right on top of each other, and then bam. Bam. Okay, so there's a couple of puncture holes right there. Okay, so now these holes are definitely going to align right there. Oh yeah, that looks good. Looks getting good. Okay. All right, you guys punctured 2 holes in each wheel. So you guys have 1, 2, 3, 4 holes punctured all together. All right. Now what I do is I'm going to go back to this scrap. Okay. And I see a nice rectangle margin right here. Well, that I could cut out of this. Okay. So I'm going to cut out this part of the scrap and get a nice long rectangle. Okay. Maybe you want to throw down a ruler and measure first and throw down a line, but I'm just going to go ahead and cut this thing. Probably a good idea to measure, right? All right. And so I got a nice long rectangle strip. I guess that got a nice long rectangle strip. All right, so rest of the steps here, I'm going to show you guys the accordion method. And if you want to go off on your own path and do the cylinders, you can. Now the cylinders, what you do is you would take 4 smaller strips, roll them into cylinders, and then cut feet in them and glue them that way. Some students last class wanted to do that. But I'm going to do the accordion. Right. Either way you do it, the next step's going to be the same for everybody. Okay. I'm going to cut this in quarters. So maybe fold this in half and half again. Okay, and then unfold it. Okay, just so I got quarter marks, right? I see 4 quarters. Okay, and cut along each one of those. Cut. 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 Okay. Now I've got these 4 smaller rectangle strips. 4 smaller rectangles. Okay. Okay. Now here's where plans might diverge. So if you wanted to roll them into cylinders and cut feet, you could. I'm going to do the accordions. I think the accordions are a little bit easier to work with. Okay. So I'm just going to fold back and forth, and I want to try to make these all about the same. Okay. So there's an accordion right there. Okay. And then just do this a few more times. Okay. All right, so got myself 4 accordions right there. Four accordions. Walk around, make sure you guys are down right here. Okay. Okay, yeah, looks like you guys are doing pretty good. Doing good. All right, so everybody with the screen, I think. All right, yeah. All right, so you guys are ready for the next step. All right, so next thing, we're gonna flip one of these wheels over and glue these around. And I guess if you wanted to like chop these in half and go for any, okay, you can do that. Just some for you guys see the purpose. It's just to provide sufficient spacing between these 2 wheels to give it the correct movement of inertia, so it's going to spin along the correct axis. Okay, so still here. There. Spinning that down. Try your best to make this pretty well balanced, right? So you want like equal mass, opposite from each other. You want the center mass to line on the center of the wheel as closely as possible. Okay. Try to make everything symmetrical.
Can we use the hole puncher?
We just use our, just have the.
Oh, yeah.
And mine are like.
All right. Press those each down for about 10 seconds and should be good to go. All right, that looks pretty good there. And then, so you guys probably see where this is going. I'm gonna throw a strip of glue on top of each of those, and then bring in my other disc. Now, remember when you glue the top disc on, you want these holes that you punch to align with each other, so you can feed the string through easily later on.
We can do black and white side, I was just.
It's just punching holes.
There.
There we go.
Alright. And one nice thing about the 4D method is you can just like press these together, and then later on I can stretch them apart to get that distance like that. Yeah, it looks like my holes are aligned. So that's all good right there. I can feed the string straight through. All right. It looks pretty good right there. Pretty well balanced. Center mass is, yeah, right at the center. So should balance right at the center. Okay. Let's see. Some of you guys are up to where I am, so some of you guys are still below, which is all right. But I'm gonna go ahead and do the next step because we're gonna actually get really close to the end here. So I'm just gonna cut some string, loop the string through, tie it, and then that'll be a wrap on this project. Okay. So I'm gonna cut a string up about 1 meter long. Right. So stretch this out to about 1 meter. And chop it right here. And then just feed the string through the holes. Right, straight through there. And then get it straight back through here. All right, so now I have a complete loop. It goes through just like that. You guys see it's like that? Okay. You guys can do that, right? Okay, and then both ends over here, I'm gonna tie a knot. Okay. So how you tie, I know probably most guys know how to tie a knot. If you don't know how to tie a knot, this is a good skill to have before you graduate high school. So here I'm gonna cross both strings over like this. Okay, right. I'll loop this under like this. Maybe like the first step of like tying your shoes, right? Like that. It's to be like that, right? Okay, and then just do that again. It's like the first step of tying your shoes, just double that. Right, so cross this again, make like an X, loop this underneath, push it through here. Okay. And then when you pull both ends, now you have a nice solid knot there. Okay. Now, if you accidentally created a slip knot, okay, well, one thing you can do is like do that step again, or tie it this way. Go around, tie it like this, and pull it like that. Okay. So that should take care of that. If you accidentally created a slip knot. Okay. So there you go. Let's look like that. I guess thing a couple of trial runs and then that'll be it. So okay, so I've seen this method where if you get this thing like rotating like this, you can wind it up. It's kind of hard to do in this confined space in front of the camera again, so I'll just do this slow method. Just wind it up this way. Get it's kind of in the middle of this thing. All right, and you need to wind this thing up quite a bit, like more than I just did, but keep winding it. Again, you can like, use the sling method, like sling it around. It should wind it up. Oh, actually, that's working better now. All right, so let me try the Benham's wheel side first, see if I can possibly get this on camera. Ooh, yeah, so that's been a little bit, but I can see the colors emerge. It's just an optical illusion. Okay. And I wind this thing up again. Okay. But then flip this over to the Newton's wheel side, check out Newton's wheel. Okay. Now I know the other Newton's wheel didn't work very well on camera, but see if at least in front of my face this works. At least we'll get a brief spin here. Ooh, okay, yeah, I think that worked all right too. Yeah, there you go. So got Newton's wheel on one side, Benham's wheel on the other side. All right. Oh yeah, we just got a couple minutes left in class. All right, so I will give you guys some points in the grade book for doing this. You guys can take this home, show your friends and family. Enjoy color theory.